first class, so we'll record this one. So, happy Wednesday, happy hump day. Couple of things. Remember that the time is short here in first semester. So we've got, God, look at how beautiful that is. It's pretty. Wow. Those of you sitting at home, this is the view that we got out here. I don't know if it'll pick up on it or not, or if it's too bright. Here it comes. Oh, maybe not. But the snow-covered trees and the sun just came out. Oh, so pretty. So time is short here in first semester. We are going to have a test tomorrow. If you want, now I'm talking to the 3 people in the room. If you guys want to take it tomorrow in class, totally fine. It won't take you more than 2 months. Okay? If you want to use tomorrow as a work day and then take it over the weekend, that's fine too. You don't have to take it tomorrow. I recommend you take it tomorrow. 1, because it's fresh. 2, because we're going to give you the time tomorrow in class to do it. And 3, that it's off your board. Okay? So I recommend that you guys take it tomorrow in class, but if not. You guys at home, it'll open tomorrow morning. I think we have it set to open tomorrow morning at 7 a.m. And then it will close Monday night. But again, sooner the better because of all the other stuff that we have going on. Okay? Also tomorrow, unit circle projects. We've had a couple of them come in already. If you are going to do a unit circle project for you guys in the room tomorrow, virtual people tomorrow, group B people Tuesday. And the only reason that they get an extra day or an extra couple of days is because then they don't have to take a special trip in tomorrow just to drop them. Okay, that's the only reason that they get the extended time. Okay? So that's tomorrow also. Anything that you got missing, homeworks, formatives, tests, anything like that, all of those need to be done by next week. Wednesday, 3 p.m. At 3 p.m., I'm going to go through next week Wednesday, and I'm going to start clicking deactivate on all of the things that need to be turned in. Okay? So that's the last day for anything missing. Then, also on Wednesday, opening up Wednesday, closing Friday is your final. It'll be in that 30 to 35 question range, and it will be all multiple choice. And it will be on InstLearning. Okay? So that will be open Wednesday, close Friday, and that is a hard close on Friday. Okay? That is after that, sorry. Okay? And that's a 20%er right there. That final exam, that's a 20% of your semester grade test. Okay? All right? So just so you know, we got that going on. Okay? So let's focus in today. Let's focus in on tomorrow's test. Next week, Tuesday, we'll focus in on the final. Okay? We'll have 4 mods to focus in then on the final for next week, Tuesday. Okay? So the test this week, we're going to have 3 basic topics on the test. It's 11 questions. Okay? This week's test is 11 questions. But 3 kind of basic topics. The first one is graphing. Okay? Tangent, cotangent, cosecant, and secant. Okay? And I'll show you how you don't have to replicate the graph every single time, that we can just use asymptotes to figure it out. If you know the two different patterns and you look at the asymptotes, we can figure that out. Okay? Second kind of topic is inverse trig functions, making sure that you know inverse sine and inverse tangent are on the right half of the unit circle. Inverse cosine is on the top half of the unit circle. Okay? And then our composition of trig functions. um, ones from the unit circle, ones that are Pythagorean triples, and then algebraic ones that we've done. Yep. So let's dive headfirst into these. So I will tell you, wink, wink, nudge, nudge, that there are a couple of identifying graph questions. Okay, so either here's the graph, you tell me which function it is, or here's the function, you pick which graph it is. Okay? So these are what the four functions look like. Those are the four trig functions that you have to do it. Cotangent, tangent, cosecant, and secant. Okay? Now, if we think about it, sine and cosine have to be less than 1. They're in that between -1 and +1 range, right? If we reciprocate them, that means that secant and cosecant have to be outside of that -1 to +1 range. Okay? So these two up top are either cosecant or secant because there's this void right here that runs through the middle of those graphs, because that nothing can be in there. Okay? So there's that void. So that's one way. That's the first thing. Do you have values -1 to +1? If you do, you're in the cotangent tangent area. If you don't, you're in the cosecant secant area. And then after that, really, I look at one asymptote. And the asymptote that I look at is x equals 0. Okay? So at 0, because now, so this 0, that's my angle measure. Okay? So I'm at 0 radians, or 0 degrees. Okay? Vertical asymptotes are where it doesn't exist. So if I am dealing with 1 over cosine, at 0, that's going to be 1 over 1. That's just 1. That exists. Okay? If I'm dealing with 1 over sine, that's 1 over 0, and that doesn't exist. Right? So because this one doesn't exist, that means it matches up with a vertical asymptote at 0, which means 1 over sine is cosecant, because everything needs a co. So this graph here is cosecant of x. Which means that this graph then over here is secant of x. Because it lies at 1. Okay. Same thing down here. Again, I look at x equals 0. I look at, so now we're dealing with, so at 0 we're either at 0 over 1 exists, or we're at 1 over 0, which doesn't exist. So this one is, so cosine is 1, so this is sine over cosine. This one is cosine over sine. That's the one that doesn't exist. Cosine divided by sine is cotangent, correct? So this is y equals cotangent, which means this is y equals tangent. Now, with that being said, I will tell you the observation that my earlier class had. They said, hey, Linz, neither one of the cos touch the y-axis. And they're correct. Because the cos, cosecant and cotangent, have vertical asymptotes at x equals 0, which is the y-axis. Okay? So that's another way of remembering. Okay? When in doubt, you can always just test a couple of points and see what the points are on the particular graph. Okay? So, but you don't really have to do any math there because you just got to look at the vertical asymptote. Okay? With that being said, you tell me what those two functions are. Left one is secant. Oh, we got.
Yeah.
Because it doesn't touch here, right?
Yeah.
We got a vertical asymptote there, so that's cosecant. And the other one? Cotangent. Yep. Love it. Next topic is inverse triggers. Okay. So what I would like you to do now is I would like you to find me those 4 values. So arctangent, I would look right side of the unit circle, but since it's negative, I'm going to specifically look in quadrant number 4. If it were positive, I would specifically look in quadrant number 1. So arctangent being negative, that would be, so I need the square root of 3 on the top, so that would be negative square root 3 over 2 divided by positive 1/2 would be negative square root 3 over 2 times 2 over 1, which then these cancel out. That gives me negative square root of 3. So I need my y value for this tangent. I'm dealing with my y value of negative square root 3 over 2, my x value of 1/2. Okay? I want to say 5 pi over 3, but that's not right because I'm in quadrant or inverse tangent. So this would become negative pi over 3. because inverse or arctangent, inverse tangent needs to be in that negative pi over 2 to pi over 2. Okay? Inverse cosine of negative 1/2. Inverse cosine, I'm looking top half unit circle. Because it's negative, I'm looking quadrant 2 only. Looking for an x value of negative 1/2. Happens right here. So that becomes 2 pi over 3. I don't have to do any adjusting with cosine. It's just whatever the angle is on the top half of the unit circle. Yes? Love it. Cosecant is the reciprocal of sine. Okay? So if I double reciprocate, so this would be the inverse sine of negative 1/2 is one way that I could think about that. So I'd be looking right half unit circle. I would again be looking in quadrant 4 because it's negative. Where is my sine, my x value, or excuse me, my y value? Negative 1/2. That's right there. I want to say 11 pi over 6, but it's got to be in that negative pi over 2 to pi over 2 range. So it becomes negative pi over 6. How did I get? Because cosecant is the inverse of sine, correct? Okay. So if I inverse the function, right, then I got to inverse or reciprocate. I'm sorry, I said inverse. If I reciprocate the function, I got to reciprocate the number. Probably a better way of saying it. Okay? Inverse tangent of 0, looking again right side of the unit circle, where it's tangent equal to 0. So that would be sine over cosine would be the only spot. I got to have a 0 in there somewhere. And so that would be right here. So that is 0. Agree with those 4? Love it. Yeah. Composition of trig functions now on the unit circle, and then we'll do a couple off the unit circle and a couple algebraic ones. Okay. So I start on the inside. So I first find where the arc sine is root 3 over 2. So I look right half of the unit circle. And it's going to be positive, so it's going to be in quadrant number 1. Where is the sine value? Square root 3 over 2. That happens at pi over 3. So this is really the secant of pi over 3. Secant is 1 over cosine. So I'm really looking at 1 over the cosine of pi over 3, which is 1 over the cosine at pi over 3 is 1/2. 1 divided by 1/2 is 2. So the secant of the arc sine of the square root 3 over 2 is 2. Okay. you try arc cosine of the tangent of pi over 4. So again, we look tangent of pi over 4. So pi over 4 is here. Tangent is going to be 1 there. So I'm looking for the arc cosine of 1. Arc cosine is top half unit circle. It's positive, so I'm looking in quadrant 1. Whereas cosine equal to 1, well, that happens right there. So this is 0. Agree? Questions on that? Let's jump off the unit circle a little bit. It helps to make a reference triangle. Now for me, I make my reference triangle in the particular quadrant that it's going to be in, either 4, 1, or 2. Okay? That's where I make mine. But I will also show you how to do it without doing it that way. Oops, tap the brakes, that's the wrong. Because our tangent is negative. That's better. Okay. So my actual theta would be there. Okay. Or if you wanted to call it right there, one of the two. Okay. Both the same. But if you wanted to draw your just a regular old right triangle, you can draw a regular old right triangle. Doesn't matter to me. Okay. And if you wanted to put your theta on this side, you can put your theta on that side. I'm totally fine with that. Okay. Tangent, or because we're dealing with arctangent, tangent is TOA from SOHCAHTOA, opposite over adjacent. Okay? So that tells me that my opposite side is negative 3, and my adjacent side is 4. From here, it would be my opposite side is negative 3, and my adjacent side is 4, provided that's where my right angle is. Doesn't matter. Okay. Then, utilizing Pythagorean theorem, we can find that missing side is 5, the hypotenuse, if you will, being 5. So this, let me move this over here. So this is really the cosecant of theta, and theta is locked in there in my triangle with those side lengths. Cosecant is 1 over the sine of theta. The sine of theta from my triangle, SOHCAHTOA, again, sine would be opposite over hypotenuse. So that would be 1 over the opposite side is negative 3. The hypotenuse is 5. 1 divided by negative 5/3 is a reciprocal. So then that's going to be negative 5/3. All good in said hood? Questions from anybody at home? Love it. What I'd like you to try now as our last one here is I would like you to try this particular algebraic triangle problem. So secant is the reciprocal of cosine, correct? So if cosine is adjacent over hypotenuse, secant would be hypotenuse over adjacent, right? So then we have to use Pythagorean theorem here to find that missing side. So I get that missing side as the square root of the quantity 1 minus 9x squared. So this is really the cotangent of theta. Cotangent is the reciprocal of tangent. Tangent is opposite over adjacent, so cotangent would be adjacent over opposite. Agree? All comes back to SOHCAHTOA. And that's the topics that are going to be on your test tomorrow. Again, I remind you that your test can be taken tomorrow in class for you guys if you want. You don't have to, though. Everybody else at home, you can take it at some point in time, either tomorrow, Friday, Saturday, or Sunday. But I wouldn't wait that long. I'd do it right off the start. I'd get her done tomorrow. Okay? Just makes it easier on you. One less thing on your plate. Okay?